Hello, I'm Fabrice Krebs, Solution Architect for Nutanix. In this demo, I will show you how to build a CI/CD pipeline by using Nutanix Stack. I've used several products and tools of the ecosystem for this demo. So the first one is Nutanix Kubernetes Engine, called NKey, and soon it will be renamed NKP. I've used as well Nutanix Database as a Service solution, called NDB. I've used GitHub repo to store my application files and manifest. I'm using GitHub Action to execute the CI/CD pipeline. In order to execute the pipeline locally, I've installed Action Runner Controller, or called ARC, which is a self-hosted runner that is used for GitHub Action. In order to deploy the application in production, I'm using Argo CD, and I'm using the GitOps principle. The application is installed by using Helm as a package manager. So what will be demonstrated during this video, it will be first the full application deployment by using GitOps principle and Nutanix NKey solution. Then I will show you how a developer can use NDB capability to clone production database into a dev database system in order for them to test their code, and then how to refresh the production database to the test to just ensure the data that are used are as closer as possible. And then I will show you as well how to commit the dev branch into production and then to redeploy the application. So let's start. Initially, we just have a GitHub main branch, which is empty, and we have Argo CD, which is deployed and that is watching the main branch. So basically what will happen is that you have a developer that will create some code, like application code and as well the Kubernetes manifest and the Helm charts. And once they're okay with the code, they will commit it locally and they will push it to the GitHub main branch. So Argo CD will detect these new commits and it will apply these Kubernetes manifest and the Helm chart into a Kubernetes cluster in a production namespace. Additionally, it will deploy as well the NDB operator. So the NDB operator is an operator that is making the link between Kubernetes and the NDB system, which is deployed on a Nutanix cluster, but which is outside of Kubernetes. So what will happen is that once the Helm chart created the different resource, a resource of kind NDB and of kind database will be created as well. And it will be the NDB operator responsibility to detect this resource and then to ask NDB solution to provision the database the way that it has been defined within the manifest. So after a couple of minutes, the application will be able to, from the front end, to make API requests to the backend, and the backend to retrieve or to store information into the database by just using normal SQL query, for example. And this is what I will demonstrate to you now. So let me switch to show you first the GitHub repo. So here is the first commit that I've done. We can see here that we have a manifest folder and we have folder for the backend and the front end. Okay. So what is interesting for us for now, it is the manifest folder. So Argo CD is pointing to this manifest and will use this manifest to install the application. As you can see here, it will install via the Helm chart some backend services, front-end services, and resources like database and NDB. And for example, let me show you what is the structure of the resource. So you can define the secret to access the NDB server. You can use the secret as well to define how you want to access the database that will be provisioned. and what is the location of the NDB server. And as well, you will define the database resource. And in that resource, you will define, for example, the size that you want to assign, the kind of resource that the kind of database engine you want to deploy, and so on. Here, it's just an example. So this is what will be used by Argo CD. So let me show you on the Argo CD side how it looks like. So as I said, this is the application that is located on my GitHub repo, and we can see another application which is the NDB operator. So Argo CD will automatically deploy the NDB operator by using the N chart provided by Nutanix. So if I take a look for the demo app, we can see under app details that it's using the repo URL that I just showed you here. And this is the resource that has been deployed automatically by Helm. So now let me take a look within Kubernetes how it looks like. So I will use the K9s tool, which is a graphical way to see the Kubernetes resource. And we can see here that we have a namespace called demo app. So this is my production namespace. If I take a look what is running on that namespace, we can see that we have 2 backend pod and 2 frontend pod, as it is explained on my presentation. And if I search now for the resource of kind database, we can see that we have a database called fkdemoapp that is in ready state, that has been provisioned by the NDB operator and NDB. And we can see the IP address that is used to access, that we should use to access this database. So now let me show back from the NDB portal how it looks like. I can go under database section, under source, and if I search for fkdemoapp, I can see my database, my source database. I can click here, I can see the look and feel, the software I'm using, on which network and so on, and I can see as well how I can access it. And it's exactly the same IP address that has been retrieved by the NDB operator. So now let me test the full setup. I can go here, I can see that I'm running on my production environment because I'm using the IP address of my Kubernetes cluster, and I will try to load the data. And as we can see here, I have already published 2 records just for the demo purpose. So it looks like the connection between the backend, the frontend, and the database is working. So now let me switch back to the presentation. So we are at this stage. But now what will be interesting is that the developer can ask a dev database solution for just the developer to make some tests. And to be very realistic, this dev production database should be similar to the production one. So this is where NDB cloning features is interesting, because in a couple of minutes, the developer can have their own database system, which is very close to the production. So it's very easy for them to make some tests and to ensure that it's realistic. And this is what I will demonstrate you now. So I'm switching to my development environment, as you can see here. And the main difference is that my frontend and my backend is running locally on my computer. It is just the database itself, which is deployed on the Nutanix cluster, and that is managed by the NDB server. So now if I just do a load data, I can see that I have the same data as the production. Why? It's because I made a clone from the production and now I have my dev environment. So it means that, let's say I want to do some tests and so on. So I will just be able to click on Add Data, Demo Dummy Data, and I'm storing it. So I can see that my development environment is up and running and it's accessible so I can do some tests. So now, let me switch back. I test the production environment. There is no new data, so it means that we have the two environments which are very distinct. But back to my presentation. Ideally, let's say that after a couple of days, or maybe every day, the developer wants to have refresh of the data from production to dev. So it will claim a NDB refresh operation. So it means that NDB will just discard the dev database, keep the database server up and running, but just detach and reattach the data or the clone of the database into the dev environment. And it's what I will demonstrate you now. How the developer can do that? He can have access directly from that NDB portal under database clone, and I can search for my own database. As you can see here, I can see from which source it is cloning and so on. I can then see my time machine. And this is the time machine that I can use to just refresh the data. But if I don't want to use the graphic interface, I can just do it by doing an API request. So I can use a solution like Postman. Here I'm just specifying, okay, I want, for example, to take the data with this specific time, and I will initiate the request. Okay, I made a request. I can go back to NDB and I can see the refresh clone operation that is triggered. So it will take a couple of minutes. So I will just make the video on pause and I will restart once it is finished. Okay, we can now see that the refresh of the clone is done. So let me switch back again in the developer environment, and I will just load the data again. And we can see that the third record is gone. So it means that the clone didn't change. I mean, the IP address of the clone didn't change, but just the database is coming back from production to the clone with the latest version. Okay, let me continue my workflow. So let's say that now the developer has a new idea. Okay, he wants to make some change on the application. So what will happen is that the developer will make some change locally on his computer. He will do the tests on the dev environment, as I demonstrated you before. And once it is done, it will commit locally and it will push it again to GitHub. But as you can see here, instead of using the main branch, which is used for the production, it will create another branch, which will be the dev branch, for example. So the following workflow will happen. As we define a GitHub action workflow, automatically GitHub will create a task or will trigger the CI/CD pipeline that will execute on the GitHub runner, which is running locally on the Nutanix host. And the GitHub runner will then deploy the application exactly the same way as it is on the production cluster, except that for the database resource, it will request to be a clone of the production database. So automatically, the NDB operator will do the clone of the database, and then it means that my front end will be again able to execute API call to the backend, and the backend will execute some SQL request to my database, which is the clone from my production. So it means that we are very close to the production system. So it will ensure that the test that we will execute within the pipeline will be realistic. So the next step of my pipeline is to make the test. So in my workflow, I will do API requests on the backend to test if the action is, or if the request will be successful or not. So I will first demonstrate you a failure of the test, and then I will demonstrate you as well a success of the test. And so the failure will just discard the commit, so it will not do anything with the commit, and the success will initiate automatically a Git pull request. And this is what I will demonstrate you now. So let me switch back here again on the developer environment. So what I will do first, as I said, I will simulate a failure of a test. So I am the developer, I'm working with Visual Studio Code, for example, and here the only thing that I will do, this is the test which is a trigger when I'm doing my CI/CD pipeline. And what I will demonstrate you is that I will try to make a record with a value of 8, for example. And as you can see here on my model, the maximum value is 5. So it means that based on my schema of my database, it should not accept the request. So it means otherwise that it can break something on my application. So I will just see that I have only one change here. I will create a new branch, test priority to 8. Okay, I have my new branch. I will just put a message for my commit, change priority from priority test from 3 to 8, and I commit and push. Okay, I'm pushing to again. Okay, let me show you now what is happening on the GitHub side. So I will go on my GitHub repo under action, and I will see that a new workflow is triggered. And this workflow will, as I said, will deploy the full application the same way that it is in production, and then we request a clone of the database. So what I will see appearing here is if I go back to Kubernetes, and if I search for namespace, we can see here that I have only the demo app namespace. So the CI/CD pipeline will create another namespace with the commit ID of my GitHub. It is just to ensure that I don't have any conflict. And then it will redeploy everything. And it will request a clone of the database. So it's just taking some seconds to proceed. Let me show you back, sorry, here. What is the status? So it is preparing, and you can see here that it's applying the NDB database resource. So if I switch back again to Kubernetes, we can see here that my new namespace has been created. I can see as well that I have pods that are created. I can see one specific pod here, which is the pod that is just executing the migration of the schema of the database once, if it's needed. And if I check the database resource, I can see that I have a new database that is in creating state with a long name here. Again, it's to avoid any specific conflict. So let me check on the NDB site. If I connect again here, I will see a clone database operation which is happening here. So it will take some minutes. And as I know that this test will fail, what I will do, I will continue my demo and I will execute another commit with a successful test, and then I will come back to this one as well. So let me switch again as a developer. So now that I know this test will fail, I know that I need to change one thing, which is the maximum of the value that I supported here. So instead of 5, I'm putting 10. I save that, and I will as well change the front end, because the front end, it's from 0 to 5 as well. So I will just go here, and I'm changing the front end to 10 as well. Okay. So let me just test locally. So I will just recreate my Docker image that I'm running locally. Perfect. So let me open it here. Use the port 8000. So again, it's working. And if I click on add data, I can see here now it's from 0 to 10. Okay, let me do one thing more. So here I've changed the backend, and I didn't just modify the schema of the database. So I still need to do one thing, which is to make the migration. So this is something which is specific to Django in that case here. I'm just telling the database engine that now instead of 5, it's 10, the maximum. And I do the migrate part. Okay, so now my database should be okay. I switch back here. I can test to add task with priority 8, and now it should work. Perfect. So I'm the developer. I'm okay with my code. Now I want to commit again. So I go back here. I still use the same branch, but I put another commit, fixed issue with maximum value to 10. Okay, this is my commit, and I'm pushing it. Okay, as a reminder, this one is expected to work. So let me switch back on my GitHub repo, and now we should see two workflow that is running. This one, which is the one that will fail, and this one, which is the one that will succeed. So I will wait a little bit because the same will happen. So it will create another namespace. It will as well do a clone of the database and so on. So I will just pause the video for now, and I will come back once everything is almost done. Okay, so now we are a couple of minutes later back. So as you can see here, as it was expected, the first test failed. And let me take a look why. We can see that the outcome of the test is this error 400, unshifted value is less than or equal to 5. And as a reminder, it was the goal of the test was to try to bring a value of 8, but the maximum was 5 within the database. So it means that if we go back now to Kubernetes, to the namespace, we can see only one namespace, which is the second test that executed, but we can see that the first test is not here anymore. So the system is automatically cleaning up as well. So if I go back here and I check the outputs, we can see that this one was the failure of the test, and then that the cleanup of the database has been done, and every other component as well. So if I go on the NDB side, I can see that the database has been automatically deleted. Now, let's take a look for my second test, which is this one, which is cloning the database. So let me go back to my GitHub. We can see here that the workflow is still ongoing, And let's take a look what is exactly doing. So it's creating the container image registry and it is pushing it to a public registry. Then it is applying the Helm, so the chart that is on that repo to install the application within my dev namespace. It applies the database resource to claim the clone of the database. And now it is waiting the database to be deployed. So as we can see here, it is waiting for a service called like this. And why is it doing that? Let me switch back here. Automatically, again, if I check for the database resource, we can see that we have two database resources on my cluster. This one is still in creating, the other one is in ready state. And the way that NDB operator is working, in fact, if I check for the namespace demo app, for example, here, we can see that once the database is created and is in ready state, a service called the name of the database will be created that will point to the database address. By doing that, it's a mechanism of Kubernetes which is used, and it's pretty powerful because instead of giving the name of the database that you don't know, usually when you deploy the application to the backend, you just let the backend know that it has to access the service like this, and automatically Kubernetes will give the IP address of the endpoint here. So it's doing it automatically. And the same will happen for my other test here. So once my database will be available, we will see the service here. Oh, now we can see that it's now created. So it means that my database is in ready state, as you can see here. So if I go back to my workflow, I can see that the test this time is completed. Perfect. So it means that this commit will succeed. And as it will succeed, the following will happen is it will delete the database clone, then it will switch the image tag of the main branch that was pointing to the old version to the new one. And this is what I will show you now. So back to my workflow. So we are here, the success will happen, and then the system will do the git pull request. So basically what will happen when you do the git pull request, I will have to accept the pull request. And by doing that, we will merge the dev branch to the main branch. So it means that you can see here that the dev branch will be the main branch. And then Argo CD will detect that what is defined on the main branch is not what is running on the production namespace. And automatically, it will remediate that, so it will recreate the resource that are pointing to the new image tag, meaning that it will use, for example, the latest Docker image that has been published. Okay, and this is what I will demonstrate you now. Basically, it will just detect and recreate the resource. And what you can see here as well is that everything that has been deployed for the test is just deleted. So the system is cleaning it by itself. So let me show you the result. Back to my workflow. So it's almost finished. Okay. So now if I go back to Kubernetes, we should see that I don't have anything anymore except my production environment that I will take a look, age 3:41. Now let me switch back to GitHub. We can see the build that it is successful. And we can see now that we have a pull request. So I go under the pull requests. I can check what is part of the pull request. There is no specific conflict. I can just decide to merge the pull request. That's it. And I can delete the branch because I'm okay with that. So now if I take a look for the code, we can see that my main branch, the latest code is, the latest change is almost now. So it means that Argo CD will detect the change. And as I said, it will remediate. So it means that it will redeploy. You can see here, it's redeploying the pod with the latest version. And now let me show you in the Kubernetes side. You can see here the age of the pod. It's now younger. And now let's see what is the look and feel of my demo of my production environment. As you remember, I didn't refresh the page yet. So previously I was able only to set priority for 0 to 5. Now I will refresh. Okay. And I'm loading the data. So I still have my production data. And now I can see that I can set the priority for 0 to 10. Let's try test priority to 9, completed, and add. Okay, it works. Okay, so now that my demo is done, we discovered that Nutanix is offering a complete solution stack that is designed to easily and efficiently be consumed by everyone. So the developer will find it simple to use and easy to integrate within their workflow. The IT teams can easily manage and maintain the infrastructure, and the platform engineer will appreciate how smoothly they can integrate within their ecosystem and the platform. So in short, Nutanix will make life easier for developers, for the IT staff, and for the engineers by providing a unified and efficient solution for the enterprise. So thank you for watching and see you soon.